And we are going to use the following property to help us do that. If you have the same base on each side. So I wrote up here a to the u equals a to the b, then u equals b. If it makes more sense in terms of numbers and things, if I said like 2 to the x equals 2 to the third, if they have the same base on each side, then you can drop that base and just say your exponents are equal. There cannot be anything else on each side of the equation. You know, I can't have a negative here or a +4 down here. It has to strictly be the same base on each side, and then your exponents are equal. So we are going to use this just to solve lots of equations today. I have a ton of examples ready. We may or may not do them all. It just kind of depends on how we're doing with it as we go through these. So if I ask you to solve 3 to the x plus 1 power equals 81. In order to be able to use this property, I have to get them to be the same base. Now 3, there is really no other way to rewrite that, so it's going to have to stay. Then my question is, can I write 81 as 3 to some power? So we rewrote the 81. Now I have the same base on each side, so I can drop the base and just say x plus 1 equals 4. Subtract the 1, so x equals 3. I can easily check these. If I put in a 3, 3 to the 3 plus 1 power is 3 to the 4th, which is 80. So B, 2 to the negative x power equals 16. You can rewrite 16 as 2 to the 4th. So that means negative x equals 4. So x is negative 4. Again, check it. 2 to the opposite of negative 4 would be 2 to the 4th, which is 16. If I said 1/5 to the x power equals 1 over 25. You have two options for this one. If you are comfortable with the fractions, you might realize that 1/25 is the same as 1/5 squared. In that, you can then just drop the base and x is 2. I also have people that really freak out when they see the fractions and they don't like them. So you could rewrite this. 1/5 is the same as 5 to what power? -1, right? Is what makes it a 1/5. So I have some people that always like to rewrite it. We know 25 is 5 squared, so since it was on the bottom, it would be a -2. So you get 5 to the negative x equals 5 to the negative 2. Negative x equals negative 2. And x is 2. That was probably a little more work, but if you really freak out with fractions, you can always flip them just by making your exponent negative. Okay, why don't you guys do D for me? Four as 2 squared. So 2x minus 1 equals 2. Add your 1, divide by 2. Everybody get that? Okay. Let's look at this. Can I just rewrite 16 as 8 to a power? No. It might work out that you have to change both of them. So what could I change both of those to? 8 is 2 to the third. You need to put that in parentheses, and then the negative x plus 14 outside the parentheses. And 16 is 2 to the 4th. Okay, I wrote these in parentheses because exponent laws. What do I need to do with these exponents? Multiply them. So this gives me 2 to the negative 3x plus 42 equals 2 to the 4x. Now we drop our base. Add over the 3x. Divide by 7. So we get x equals 6. What would I change these to? So 27 is 3 to the 3rd. Yes, ma'am.
So if they are similar, you don't have to break the 3 down?
Right. And
if it's already simplified?
Yes, if it won't go any smaller, or as long as you can rewrite the other one as that number to a power, you're okay.
Now what if we can't get the,
If you can't get the same base?
Yes.
At this point, I won't give you one of those because we don't know how to do them yet.
Okay.
In the next section, we'll talk about how to do those problems. So this becomes 3 to the 6x. So x squared minus 7 equals 6x. What would we have to do here? Subtract over the 6x. And then? So what multiplies to negative 7 and adds to negative 6? we get x equals positive 7 and negative 1. So it is still okay. You might get more than one answer on these. And again, you can always check them just by plugging them in.
You'd have to plug in each one individually.
Yes.
So if one of them doesn't work, is the whole thing wrong, or do we just not use that one number?
You wouldn't use that one. For these types of problems, they really both should work, so if something doesn't, you probably made a mistake. But in the next section, we will have problems where things don't work, so not a bad idea just to get in the habit of checking now.
Sounds like I'm not going the next section.
Oh. Just because you have to check your answers. Okay, any other questions here? Do you guys remember doing this at all in Algebra 2? We did just a very little bit of it. Okay. I am going to jump around a bit. I want to do this one. So what would I need to do here?
We've done it now.
And you would change it to? So then
You distribute the little x power. And then you drop the 3's. And then x.
Just move it over and put it something else.
bring everything to one side, and then you can take out x, which would leave me with x squared minus 2. Okay, so you could try to factor the x squared minus 2, or you could solve it from here. It doesn't matter. If you set those equal to 0, you get x to be plus and minus radical 2 and 0. Okay, and you can check all of those, plug them in, and they do work. Questions on that one? Let's do something more interesting then. It is interesting. Okay. You cannot multiply with those exponents unless the base is the same. So I can't say this is 8 to the x cubed power or anything like that. Yes?
Can we just get rid of the power? Because
How?
so like we'll put it the 2 under a radical, like we'll square it kind of like that and get rid of it.
Yes, you could add square roots to each side. I'm not sure that's going to help us get to the answer.
If we just break each base into powers of 2.
Okay, let's try that. So if I have 4 to the x, I could rewrite 4 as 2 squared to the x. 2 to the x squared I'm going to leave alone. 16 I would write as 2 to the 4th squared. So I have 2 to the 2x times 2 to the x squared equals 2 to the 8th. Now what? Can't drop them yet. We can only drop them if there's only one base on each side.
Multiply.
Okay, when I multiply these, what do I do with the exponents? add your exponents. If you drop your base too soon, you'll end up with the multiplication and it's going to throw off your problem. When I drop that, you just add these.
Why are you not multiplying 2 and 2?
It's just like if you take x squared times x to the 4th, saying you have 2 x's here and 4 x's here, so altogether it's just 6 x's. So we don't actually change the base, we just change the exponent, the number of them that we have. So now we can drop the base. I'm going to bring over my 8 and I'm just going to reorder this. Then we can factor. Okay, if we set each of those to 0, we get -4 and +2. Right. Do that one. Base can be anything. So it doesn't matter that it's an e, it's the same on each side, so you just get to set the exponents equal. So -2x equals 8, and x is -4. We're going to do just a few more. What would I do? You could. That would work. You could also, if you wanted to rewrite 1 over e squared, you could turn it into what? E to the -2. So both options will get us to the same point. And then when you multiply those e's, what do you do with your exponents?
Wait, I have a
Yeah.
question. Why would we change it to the -2 and not just keep it like a -1?
You want to change the exponent itself. When we say you flip floors because of a negative exponent, you're not putting a negative out in front of it. It's the exponent that becomes negative.
So no matter what, it will always.
If you're changing floors, you change the exponent. We are multiplying those, so you add your exponents. Now we have an e on each side, so we can drop the exponents. Then what? Subtract the 3x, add the 2. What multiplies to 2 and adds to -3? -2 and -1. So you get x equals 2. All right. Questions there? We're going to do just a couple more. Have to give you a really pretty one before we can say we're done.
Can we just bring out 3? Can we just skip this one?
Oh, now.
That was
If it's a cube root, you could cube each side.
Or can't you like
Five
divide
to
to
the
the
next
one?
Five
Or
to the 1/3.
divided to the 5 to the 1/3. So both of those options are good. So a cube root is the same as a 1/3 power. How would I want to rewrite this 1/5?
Uh,
5 and to the negative.
Yes,
Okay, power to a power we multiply. So then we can drop our base. Then what? Add our x. Negative 1/3 plus 1 would be a 2/3 x. Equals negative 2. Divide by 2/3. And negative. So we can do them with radicals as well. Just rewrite it as a power. Or take each side to a power to cancel. I do want to tell you, if you had chosen to cube each side to cancel this, that would be fine. Those would drop, so you would have 5 to the negative x. Over here, you would have to multiply that 3 through your exponents to become a 3x plus 6. If you go that route, and then you don't have the fractions.
Then what was you do with oh, never mind, that was the other question.
And then you just, but 5 to the 1/5, so then you have change it to 5 to the negative 1.
And then go like through like we did. Yeah, Montana? Yes. Anything else? I just want to throw 2 more problems up here. This one, there are 2 different options for how to do it. We could change everything to 2's and proceed from there. You could also, if you look at this, does this 2 have an exponent or just a 1? We don't have a variable that we have to worry about. So is there a way I could get rid of it?
To divide.
You could also divide by 2. As long as you don't have any variables in your exponent, you are welcome to just divide it over and give yourself an easier problem to solve. And so then we can go, we can't rewrite 32 as 4 to a power, so we'll have to go down to 2's. So 4 is 2 squared. 32 is 2 to the 5th.
I divided 4 by 2.
yes.
To the 5th.
So 6x equals 5, and x is 5, 6. So that one, again, there's 2 options. You could take everything to 2's, or since that 1, 2 didn't have a variable exponent, you're welcome to divide it over. Final example.
This is the one that you skipped, not the last one.
Oh.
Yeah.
But this one is so pretty. I have to get a common base, right?
What?
You're right. I don't know if you know why you're right, but
Because I mean,
Yeah.
you can't break 5 down. But 5 to what power equals 1? 0. Anything to the 0 power is 1.
Oh.
Oh.
So you can change one to whatever base you need, just by making the powers equal.
Oh, that's convenient.
Isn't it?
Such a useful tool
That's
to use
just
in
not being
everything.
able
Okay, are there any questions here? We have quite a bit of time left, got about 20 minutes. There is a worksheet posted on Classroom for homework, and you've got time to work and ask the questions.